Public transport weaknesses. First, mismatched schedules. Bus schedules are designed for 9 to 5 workers and not students. When classes end slightly after the hour, students often miss the bus and wait a long time. Second, the last mile problem. Buses may stop near campus, but students still need to walk far to reach their classes or libraries, making public transport tiring and inconvenient. Third, poor real-time information. When bus app shows wrong location or ghost buses, students lose trust and switch to ride-hailing services instead. B. Transport demand issues. First, peak hour surge. When thousands of students move at the same time, buses become overcrowded and some are forced to wait. Second, dependence on private cars. Limited public transport pushes students to drive, causing traffic congestion and parking shortage. Third, nighttime safety demand. Late night classes and activities increase the need for safe transport. Without night shuttles, students rely on expensive ride-hailing or personal cars.
Campus planning weakness. First, a poor accessibility and connectivity. Building hostel, parking areas, and bus stops are often far apart and not well conducted. This makes moving between class, facility, and resident time consuming and physically tiring. Second, inadequate infrastructure capacity. As student numbers grow, classroom, workways, parking areas, and common facilities struggle to cope. This leads to overcrowding, congestion, and reduced comfort during peak hours. Third, a lack of student-centered design. Many campus layouts overlook student needs such as safety, comfort, usable access, study space, and social area. This negatively affects learning quality and overall campus life. Infrastructure limitation. First, topographical and spatial constraint. Iaitu puncak alam, hilly, green landscape, limit physical expansion. The terrain require constant monitoring, and heavy monsoon rain can damage road or slope, making repairs slow and costly. Second, non-resident housing gap. Limited on-campus accommodation force many students to live off campus. This increased pressure on surrounding roads and public transport, which are not designed for large student commuter volumes. Third, inadequate transport and parking infrastructure. Bus stops are too small, poorly ventilated, and lack covered walkways. Parking shortage lead to illegal parking, traffic congestion, blocked emergency access, and unsafe conditions for pedestrians.
Public transport enhancement. First, improve bus scheduling and frequency. Bus timetables should match student class schedules. Increasing bus frequency during peak hours can reduce long waiting times, overcrowding, and encourage students to use buses instead of driving. Second, improve real-time bus tracking. Mobile apps and digital displays can show live bus locations and arrival times. Accurate information reduce uncertainty, builds trust, and makes public transport more convenient. Third, introduce minibus. Minibus are ideal for short roads and low-demand areas. They are cost-effective, environmentally friendly, and flexible for campus and residential roads. Demand management, reducing private car use. First, encourage carpooling. Carpooling platforms and incentives like priority parking can reduce traffic congestion and parking demand while saving costs for students. Second, extend bus operation until midnight. Late night bus service supports students with evening classes and activities, offering a safer and more affordable alternative to driving or ride-hailing. Third, extend bus coverage to transit hubs. Connecting campus buses to MRT, LRT, and train stations promotes seamless public transport use and reduce reliance on private cars.
Sustainable active mobility. First, provide free electric scooter and e-bikes. UiTM Puncak Alam can offer free electric scooter and bicycle to help students travel short and medium distance within the large campus. This zero-emission bicycle reduce reliance on shuttle bus and private car while supporting a greener campus. Second, add more cover walkway. Convert walkway connecting hostel to faculty building protect students from hurt and train. Comfortable and safe walking route encourage students to walk more, reduce shuttle congestion, and improve accessibility for all users. Third, introduce an e-merit working campaign. Using apps like Strava, students can earn e-merit points by walking around campus. This promotes healthy lifestyle, reduce transport demand, and help the university identify high user working route for future improvement. Infrastructure and technology solution. First, IoT-enabled shuttle tracking. GPS and IoT technology can provide real-time shuttle location through mobile apps or digital display. This reduces waiting time, overcrowding, and improve overall shuttle efficiency. Second, student-led maintenance reporting. Students can report damaged facility using QR code or online form. Faster reporting lead to quicker repair, safer facility, and a more comfortable campus environment.
KPI for sustained campus mobility. First, percentage of students using sustainable transport modes. This KPI measure how many students walk, cycle, or use campus shuttle buses instead of private cars. A higher percentage shows lower carbon emission, reduced congestion, and better use of campus transport systems. Second, average campus travel time during peak hours. This indicator tracks how long students take to travel between hostels, faculties, and the library during busy periods. Shorter travel times reflect improved transport efficiency, better route planning, and supportive infrastructure. And the third, campus mobility satisfaction level. Through regular student survey, this KPI measures satisfaction with shuttle reliability, walkways, safety, comfort, and accessibility. High satisfaction scores indicate a well-planned and student-friendly mobility systems.